Hi, welcome back. This is number 8 in the Helm mini course series. If you're enjoying this series, then I hope you'll consider subscribing if you haven't already, and maybe giving a thumbs up. This video is all about Helm Pull, which will show you how to really take control of Helm charts by downloading remote charts into your own source code repository. Is definitely something you want to do. There's full links in the description below to my full Kubernetes and Istio courses. Let's get started. So I'm glad you're back after my previous video where I was ranting about the dangers of using Helm install on a production cluster. A snowflake cluster, and that's the cluster where we've applied upgrades and patches and Helm installs in an ad hoc fashion, is a really dangerous thing for a project. Now, doing Helm install is okay if you're doing what we're doing on these videos. We're on Minikube and we're just experimenting and trying things out. But if this were a real project, this would be a disaster because it would be very difficult now to restore the state of this cluster if we needed to move the cluster to some other hardware. For one thing, we'd have to remember all of the charts we've installed, but another big risk is that, well, all of these charts we've installed were remote charts. So by the time we come to restore these charts, they might have gone away. They might not be supported anymore, or the URL or the structure of the charts themselves might have changed dramatically. What we need to do is we need to be able to restore a cluster using files that we can store locally and of course store in source control, such as Git. And it's perfectly easy to do that using Helm. There are in fact two techniques, so we'll start by looking first of all at using Helm Pull. So in order to explore Helm Pull, I think what I'm going to do is I'm going to get this cluster back to being empty. It doesn't matter how we do that. You could do a Minikube delete just to throw this cluster away. Or we could use Helm. If we do Helm list, that will give us a list of all of the installations that we've applied to this cluster so far. We have monitoring, and I did it as a kind of throwaway example in the previous video. I did that MySQL install. Well, of course, we can now do a Helm uninstall of, first of all, the monitoring. Don't worry about the warnings as usual. And the my-sql- install. And it might take a while, but before long, all of the resources that were created by those installations should be removed. So let's run through the example of where we're setting up a new cluster and we need to install monitoring and MySQL just as an example. And we want to do this in a repeatable way so we can avoid a snowflake cluster, and we want to get into the situation of having a Phoenix cluster that we can restore whenever we want to. So to go through this example, I think I'll just create a directory to work in. So I'm going to call this my cluster config. And what we can do, instead of using Helm install followed by the name of remote chart, which immediately goes to our cluster and starts making patches to that cluster, we can instead use a command called Helm Pull. It was previously, by the way, called Helm Fetch, and I keep forgetting that. I still use Helm Fetch, but this is reminding us that the command is actually now called Helm Pull. Now, it requires an argument, and this allows us to specify either the URL where the chart is located, so that would typically be the GitHub repository of the chart, or if you've worked with the Artifact Hub, as we did in the previous videos, you can use exactly the same parameter that you would have used for Helm install, where we have the repository and the chart name. So, for example, we could do a Helm pull, and then I'll use the repository and the chart name. If you remember all the way back to when we first installed monitoring, I set up a repository called prom-repo, if I remember correctly. I could confirm that with Helm repo list, but yeah, that's definitely what it was. And the chart name was cube-prometheus-stack. The difference between this and the install command is this will just download the source code for that chart, and it's not going to touch my cluster at all. So if we do that, Assuming I've got the syntax correctly, no errors reported. But unfortunately, if I look at the results, if I do a directory listing, now all it's done is it's downloaded it's a tarred and zipped file. So it's some kind of compressed file. Now I could go ahead and fiddle around uncompressing this and untarring it. If you know how to do that, it's pretty simple, but there's no need to do that because one of the flags on Helm pull will do that automatically. But I must admit, I can never remember how to do that. So if I do a Helm pull -- help, then that will give me the help page for pull. It always surprises me. There are quite a lot of options or flags that are available for this command. Most of them you'll probably never need to use, but you can see that there is a -- untar, which we can set to true. It will untar. That means it will unpack the chart after downloading it. So let's have a go at repeating that previous command, and it was -- untar equals true. Let's try that. And this time around, well, we've still got the previous. Let's remove the previous download, that Kubernetes stack ending in this extension. I'll get rid of that. And we've left now with one folder. The folder has the same name as the chart name. And if we go into there for the first time, we can see we've quite a lot of stuff in here. And this is actually the full structure of the source code for a chart. Now, when we run Helm install, or in fact any of the Helm commands, it uses all of the information in here, it crunches that together, it actually passes it through a template process, and out of that will come standard Kubernetes YAML that can be applied to a cluster. In other words, what I'm trying to say is what we can see here is the full source code for that chart. We will be looking in detail very shortly at the structure of this chart, and in fact I'll be showing you how you can build your own charts, and we'll see the great value of building your own charts. But for now, I just want to draw your attention to the fact that one of the files in that chart is called values.yaml, and you're very familiar with that file now because that's exactly the same as the values.yaml that we've been working with. That's the way that we can configure and tune any particular chart. I'll open this chart folder up in a text editor so you'll recognize this values.yaml file. In fact, it's exactly the same file that was generated when we used the Helm show values command. This was the file that we used as a basis and a starting point for writing our own values.yaml file. So we'll come back to that in a moment, but the point I want to make is now already we're in a much stronger position than we were previously if this were a real project, because we now have a folder containing everything we need to rebuild that chart at any point in the future. So even if that GitHub repository goes away, if the Kubernetes stack project is no longer supported, we probably want to migrate, but it wouldn't stop us reinstalling this chart on our own servers independently of what happens with that remote chart. And of course, I could go on. In the my cluster config folder, I've got the chart for Kubernetes stack, but I could now continue the process and get all of my charts. If I go back to the Helm pull command, I could pull from the Bitnami repository the MySQL charts. Just like that. And now I've got both charts. So I won't go into full details of how you set up configuration control for a live Kubernetes project, because the details of how you do that vary depending on taste and so on. But I hope you can see here, at least we've got the basics of a configured system. So now that I've done that, I've got all of the source code for all of my charts. But remember, if I do a kubectl get PO, I don't currently have anything installed onto my cluster. Now that we've got the charts locally, we don't need the remote charts anymore. Anytime in the future, if I need to rebuild a cluster, I can just go through all of these charts and install them one by one. And of course, I could write a script to do that as well. Now, I'm not going to get very sophisticated in this video. I hope I'm just giving you the kind of the good starting point that you would need for a real project. So I will do things manually here, but I hope you can see it would be a pretty simple job of scripting this process. We can now go ahead and use Helm install, but Helm install on these local downloaded copies instead. How do we do that? Well, it's very simple. I would just do Helm install. As before, I would need to give the installation a name, so I'll call it monitoring. And now, instead of using a repository name, I don't need the repository anymore. I can just use my local folder, and it will use the contents of that folder to run through its processing to generate genuine Kubernetes YAML that it can apply to my cluster. Let's see if that works. And we can see already that we're getting those warnings as before, which doesn't look pretty, but it means it really is applying real, proper Kubernetes YAML. And there we are, we're in the state of deployed. And as I say, the details of this would vary from project to project, but I hope you can see now the fact that we have our own copy of this. We could very easily write a script which simply goes through each of these folders, installing each chart in turn. So I'll just simulate that by doing this manually. I can now do a Helm install for the MySQL installation. And again, instead of supplying the repository and the chart name, I just supply this local folder version instead. Yes, I thought I had an error there at first, but there's just a lot of output from this. It is deployed at revision 1. So there's no big difference really, other than we've taken our own local copy of the source code for these charts. If we now do a Helm list, we can confirm that we now have monitoring and MySQL installed. And of course, that should also mean if we look at the Kubernetes cluster itself, we now have pods and services and all the usual kind of stuff. Now, I realize that what we've done now is we've gone back a step, really. We currently have the source code for, and we're installing the chart exactly as it appears in the remote repository. In other words, it doesn't have our customized tunings. In particular, the service is back to that type of cluster IP. So to clear that up, if we go into the chart, remember there is a values.yaml file. Let's open this up in a proper text editor. And remember this values.yaml file is that big 2,500 line file that the chart needs to define all of the default values for this chart. Now you'll remember that we had a version of this file which only had about 5 or 6 lines in it, and they were the overrides that we wanted. Now it's a bit of a mistake here. We can't delete all of the values from this values.yaml file and then just provide our small version, because this is the source code for the full chart itself. So we absolutely need all 2,500 lines in this values.yaml file. So again, it depends on your project what you do here. Now you could absolutely edit this values.yaml file. It's your own local copy, and after all, you're in complete control of it. So we could, exactly as previously, we could find that service block. In fact, it's the service block for Grafana, isn't it? So if I search for Grafana : it's just a little further down that we have this service block. Now we could go ahead and we could add in, if I remember correctly, it was the type node ports, and then node port was 30,001. You could do that, and obviously you would commit this change to your source control system. Now the problem here, of course, is that now this file has now diverged away from the official values.yaml file that comes with this chart. And that could cause configuration management problems in the future. Let's say, for example, you want to upgrade this stack, and let's say in a year's time, they've produced a new version. It would be really awkward, because when you download that new version, they're going to have their own values.yaml file, which will not have this block, and they could have made some major changes in the rest of this file. So really, I would suggest we want to I'm going to undo those changes and just go back to exactly how it was. I, in general, would recommend keep that values file exactly as it is. And what we'll do is we'll create a separate file. Now, I've just gone ahead and done that off camera. I've called this version myvalues.yaml, and it's exactly the same as the values.yaml, that reduced version that we had some time ago. I've just got the overrides that I need. Now, this itself isn't ideal. I've put the myvalues.yaml file in with the rest of the chart, again, to help future upgrades of this chart if I'm going to go and download a new version of this chart. In practice, I would keep this separate outside of this chart. That's a detail I won't worry about here. That's pretty simple to resolve. It keeps things simple here, though. So now I've already installed this chart. If I hadn't, then I could absolutely do a Helm install at this point. But just as before, I can perfectly well do a Helm upgrade as well. So I'm going to upgrade my monitoring installation, but I'm going to provide a custom values file using --values equals myvalues.yaml. So just to be clear, this is going to use all of those 2,500 values inside values.yaml unless there is an override in myvalues.yaml. Exactly what we want. As before, the final parameter is the directory name that the chart's stored in. Now, because I've been moving folders, I'm now inside that chart directory. So it's absolutely fine to use a dot to say it's this folder. If I change directory to the upper level, then this parameter would be /cube Prometheus stack. I hope that makes sense. Shall we see if it works? Let's give it a try. Always a good sign when we see those warnings. And we're now deployed at revision number 2. Just as before, I'm going to do a very quick check on kubectl get PO, and I wasn't quite quick enough, but the Grafana chart has restarted because we can see that it's a very young pod, this, compared to all of the other pods. So that's a good sign. And similarly, if we do a kubectl get svc, wonderful, it is picking up that we want a node port. And always check that your changes have applied. So that's one way of doing it, but there is another way, and that is you don't have to install these charts. Instead, you can generate the Kubernetes YAML. And I think we'll do that in the next video.